Hey y'all, it's Miss Lloyd, and we are looking at inverse functions today. So an inverse function is just reversing the x and y values of a function. Some commonalities are it reflects across the y is equal to x line, so that identity line, it reflects across. And you're basically just trading each and every x and y point. So looking at this first one in blue, y is equal to 2x plus 3. I can see a point right here is 0, 3. So then if I flip that, I would end up with 3, 0, which is one of my points that's on this side. And it keeps happening. So all the y values just go to the x's, all the x's go to the y's. It reflects over that y is equal to x line. When we're verifying inverses, we can plug the first function into the second. When it simplifies, so we're doing a composition, so I could write this as the first function, we're plugging the second function into it. That should simplify to x. Same thing if I were to plug the second function into the first, or vice versa. So we're changing and we're putting the other function in. That should also simplify to equal to x. So that's how we check if these two f sub 1 and f sub 2, if those functions are inverses of each other, they should simplify to just x. So if we're trying to find the inverse, I have this function where f of x is equal to 1/5 of x. So the first thing I want to do is replace my f of x with a y value. So if I'm going to switch x and y, I need to have a y to switch the x with. Next, I'm going to do the switching. So just the x and the y are going to trade places. Now that my x and y have traded places, I'm going to solve for y. We always end up with y equals. Now that my y value is alone, I'm going to replace my y with the f to the negative first of x. So what this is not technically an exponent. It's a notation of saying that this is the inverse function. So that negative 1 is saying inverse. And then we're done. So now that I've found the inverse function, they now want me to verify that it's the inverse function by plugging them in, and it should be equal to the identity function. So I should simplify to x. So I've got my original f function, and we're plugging in the new one that we just got, that we just made. So then the one we just made was 5x, and we're plugging that into the original f function. So simplifying this, my f of 5x, or my f of the inverse function, is going to give me just x. That one works out. So I'm going to trade places. And this also simplifies down to just x. So verifying that these are indeed inverses of each other. We did it right. All right, next we're going to look at which function is the inverse function of this thing. So what I'm going to do first is just kind of test to see if it is an inverse. So we can do this just to see if something is an inverse or not. We're going to plug one function into the other, see if it simplifies to x. So I'm going to test first plugging in the g function to the f function. And then I just simplify. Because this ends up simplifying down to x, we know that these two are inverses. Next bit, we're going to look graphically at the functions f of x and g of x, and we're going to verify that those are inverses of each other. So when we're looking at the graph, we want to make sure that the points line up with the inverses, so switching the x and y, and we can also see if it's reflecting over the y is equal to x line. So you can draw that y equal to x line first. It's really nice, you just connect the corners. So they want me to graph while x is greater than or equal to 0. So I'm going to make my little t-chart for that. This is my f of x function. So if I plug in 0, 0 squared plus 1 is going to give me 1. 1 squared plus 1 will give me 2. 2 squared plus 1 will give me 5. And so I'll graph that part. So this is the part of the graph that they want me to show because they said just greater than or equal to 0, so I'm not going to graph the other half of it. And then we want to graph this other function. So our square root function, so our g of x, the parent function, we would plug in 0, 1, and 4, so things that we know the square root of. And we would end up with 0, 1, and 2 when we take the square root of each of these. And then I have this minus 1 in here, which means that everything's going to be shifting over to the right. So we're basically adding 1 to x. So these x values will change from 0, 1, and 4 to 1, 2, and 5. Oh, would you looky there? The x values here match the y values there, and the y values here match the x values there. So there's a good, indication that we're on the right track. And then we can see the mirror reaction between the orange and the green here. So one-to-one functions, we look to see if they are one-to-one functions, if we can do the horizontal line test. So it's just like the vertical line test, just with horizontal line instead. And so if it passes the one-to-one, if it is one-to-one, that means that it does have an inverse function. So here they want us to use a graph to determine whether the function has an inverse. So looking at this, I just have a variable to the first power and x to the first power, so I know this is linear. So I'm going to distribute this in so that I can put it into slope-intercept form. So graphing this, I'm going to start on 1.5. And I'm going to be moving down 1 and to the right 2. Or it could also go up 1 and left 2. So then to tell if this is a one-to-one function, I'm going to draw a horizontal line and kind of move it across and see if there's any place where I would cross more than once. So moving this up and down, there's not a single part of the dark blue line that is being crossed by the light blue line more than one time. It's all just once. So this is a one-to-one function. So that means it has an inverse. Next one, we're going to find the inverses algebraically. So again, we're doing the same that we did above, to where I'm going to replace my f of x with my y. Everywhere I have an x, I'm going to replace it with the y, and everywhere I have a y, I'm going to replace it with x. I don't like that this is a fraction, so one of my first steps when it comes to solving for the y is to get rid of the denominator and move it to the other side. I have two y's, and that's not my favorite thing, so I'm going to move my y value to the other side and move the 2x that doesn't have a y to the right side. I now notice that I have a y in common for both of these terms, so I'm going to take the y to the outside, like a GCF, because it is a GCF. Now that I just have the one y, I'm going to divide over the stuff that isn't y. And so I now know y is equal to this fraction. Now that my y is alone, my last step is to just change out my y for my f of -1 of x. And we are finished. Ta-da! And the last one I'm going to say for my kiddos because I like them more. All right, so if you have any questions, you can always comment below. If this was helpful, please like and subscribe. If you think that someone else would find this helpful, please feel free to share. Spread the love.